Hello, this is Paul from Forces Tech. In this lecture, I'm going to introduce the second part of fundamental, okay, and the most important theorem. And this part we're going to use to find the definite integral. Okay. So here is part 1 of 2 because in the next topic we have the part 2 of 2. Okay. Look at the theorem. So suppose f is a continuous function on a b, still the same. The part 2 result is, okay, so here is what? The integration or integral of the continuous functions, how to calculate it. So how to calculate it? So we use this is a notation. This notation means the difference between the functions at a and b, the difference of the function. So what is the function capital F? The integral function is lowercase f, and this is capital F is what? Is any antiderivative of f. Remember the first part 1, we know how to find the antiderivative, right? That means we easy to find the antiderivative of f. If we find the antiderivative and then use the distance, and then we can find the integral. I will give you a proof here. So first, this is the most important theorem, okay, the most important theorem in calculus. Okay, so I'll put one more. Okay, the most important. I will give a proof here. So we'll give a proof. So remember, so in that derivative we can use the part 1 of fundamental. Okay, remember part 1 of fundamental, how to find the antiderivative of f is this. Okay, we're going to do, so we set up a capital F function is this, is the integral from 0, if I say from 0 to x, okay, whatever you can change this, no problem. F t dt. Remember part 1 of fundamental tell us this is a continuous function, and also, and this take a derivative goes to f, right? Or we can this, and then what? And then f take a derivative goes to the capital F goes to lowercase f. Okay, and this is what? This is a fundamental, right? So this is a fundamental. It's a part 1. Remember, this is fundamental part 1. Okay, and it means what? Means so these functions, capital F, this function what we defined it is antiderivative, right? Antiderivative of fx. Okay, so that's exactly what we find. Of course, you can plus c to get all the antiderivative functions, right? Or you will say, but I will not use c. Okay, so everyone you know, remember this: one antiderivative plus c. What is? C is a constant, any constant number. This is all antiderivatives. Okay, antiderivatives. It's all antiderivatives. But we don't need to use c, or you can use c to get the same results. It's good. Now we have f, right? So we can work on from the left. See, what we need to do is find here a to b f x dx. So how to find this? I easily to use the property we have from 0 to b. Remember this property? F x dx minus 0 to a f x dx. Okay, this is the addition rule, right? How do you say, if we say add this to the left, 0a plus a to b, of course is 0 to b, right? Okay, so good. If we have this, now we can. So what is the definition of capital F, right? But it's a capital F at b. Okay, so this is the first. I mean, this one is easy to compare. Okay, so this definition, and this is just capital F at b. So what is this? of course, is capital F at A. See, that's done. So the integration can go to the difference of the antiderivative functions. If you want to consider C is okay, C minus C is equal to 0. They are the same. Okay, so very easy, right? So if you have part 1, very easy to have part 2. So very, very important. Now I give you 2 examples. So how to use this to find the definite antiderivative? Here the first example. But before we go into this, we need to review a little bit in Calc 1. So what is the antiderivative of a power function? If the power function is here, okay, if we have a power function here as a power function, what is the power? The power is n. What is the antiderivative of this? So capital F. Capital F is the power function, but the power goes 1, and then we have a coefficient. Why we have this? This is the result from Calc 1. Why we have this? I do calculation here. Okay, see, let's do calculation here. And this take a derivative definitely go to here. Why? Okay, I going to do calculation. X raised to the n plus 1's power over n plus 1. This is capital F. We take a derivative. You remember this, right? This goes down. Okay, so n plus 1 times x, the power goes down 1. This is the derivative of that. And then over n plus 1. And now you know, right? So when we cancel this coefficient, that's what we get. We get x raised to the nth power. That means capital F take a derivative goes to lowercase f. So this is good. Keep in mind that this is very, very important for us to find the antiderivative. This is the first antiderivative. Now we can use this. Why? Because this is a power. This is power, this is power, this is also power. Okay, this is a polynomial function. So now we're going to evaluate the part 2. A fundamental tells us what we need to do. If I say this is lowercase f, whatever I use fx. All we need to do, this is what? This is a power function, right? We need to find what? We do this. All we need to do, we need to find capital F, antiderivative, okay? If we find it, this is an antiderivative. Okay, if we find this, then we have everything. Okay, the difference is the integration. Now we're going to find. So what is the antiderivative? Antiderivative is the antiderivative of first, antiderivative of the second, antiderivative of the third. So which means this. We find the antiderivative of this. Easy to find, right? This antiderivative what? The power is 1. Okay, we use these results, which is x raised to the 2 plus 1 is 3rd power, and the bottom is 3. Take a 3 down. See, and this is the first. What is the second? Of course, the second everyone knows is x squared, right? And divided by 2, we cancel this 2. And the minus 4, which means minus 4 times x. See, this take a divided go to 4. This take a divided go to 2x. This take a divided will go to x squared. So this is the antiderivative. This is at least 1, okay? So this is a 1 antiderivative, okay? Antiderivative. And the fundamental says any antiderivative is okay. You don't need to plus c, okay? This is at least this is 1 antiderivative, okay? It's good enough. And then so we can do calculation. So what we have is there, right? So I say this, the integration from 1 to 3. This I use fx, and dx equals what? Remember that? Equals antiderivative, any antiderivative f at this minus f at 1, right? The difference of antiderivative between 1 and 3. So this is from this is definitely from the fundamental, okay? From the fundamental. Of course, is part 2. This is part 2. Yeah, good. And then we just do calculation. What is f at 3? You can plug in. What is f at and plug in, right? So I plug in here. So I have to use this log is 3 raised to the third power over 3, right? Plus 3 with the second power minus 4 times 3. So this is f at 3. The same. F at 1 is 1 raised to the third power over 3 plus 1 raised to the second power minus 4 times 1. See, super easy to calculation. And then whatever you use the calculator, we get how many? 26 over 3. Yeah, this is the example. Super easy to do calculation. Okay, if you know this fundamental, okay, the second part of fundamental. One more example. The last example here is evaluate this definite integral. Is this a power function? Look is not, but it is, right? It is. Okay. Why? We can change a little bit. Okay. So this is fx. Okay. This fx exactly is a power function. It's still a power function, right? It's still a power function. If it's still a power function, whatever the results, we just get the antiderivative of a power function we can use. What do we do? So now, you know, right? So first we find the antiderivative. What is the antiderivative? Remember the results. This power is 1, which means x raised to the 1/2 plus 1 is 3 over 2. Okay, the new power divided by the power is 3 over 2. Okay, you change the form. Divided is times the flip, right? Flip the bottom. Yeah, and then x raised to the 3 over 2 to power. So this is the antiderivative, right? Okay, so this is an antiderivative. This is an antiderivative. Antiderivative. Now is good. Fundamental we can use. So if we use the fundamental now, 1 to 9, there's f x dx equals what? Equals f at 9 minus f at 1, right? The difference between what is f at 9? We plug in. Sorry, this is 9, right? This is 9. Okay. Times 9 raised to the 3 half 3 over 2 and minus f at 1 2 over 3 times 1 raised to the 3 over 2 to the power. Of course, we do calculation. What we get is 52 over 3. That's the results. Okay, and that's all. Thank you.